You are looking at the scaffolding of clouds. The clouds in the sky are not composed of pure water. They need particles called aerosols to act as scaffolding for water droplets to condense on. The behavior of clouds depends on the type of aerosols they cling to. These particles can change the freezing temperature of water, which induces rainfall, by as much as 30 degrees Celsius, creating immediate climate impacts. Water is by far the most abundant greenhouse gas, often 100 times more abundant than CO2, and it has the greatest impact on our climate. While CO2 buildup in the atmosphere over 2 decades can raise temperatures by 1 or 2 degrees, aerosols in our atmosphere directly impact climate by altering water's freezing temperature immediately and influencing its behavior in the atmosphere. Biological aerosols, shown in green, particles from plants, trees, grasses, shrubs, fungi, and bacteria. Life in the ocean also produces biological aerosols that cloud seeds at warm temperatures, catalyzing rainfall at 20 to 30 degrees warmer temperatures and significantly lower concentrations than mineral-based aerosols. These aerosols support consistent rainfall and enhance cooling. In contrast, mineral-based aerosols originating from desert dust like the Sahara, soot, and ash suppress rain by lowering the freezing temperature of water, much like antifreeze in your car's engine. Clouds formed on mineral aerosols often condense and evaporate repeatedly, sometimes without producing any actual rainfall. The bare ground below creates a heat bubble, further suppressing precipitation. Plants do more than provide shade and greenery. They actively support rainfall. Biological aerosols seed clouds and promote rainfall at warmer temperatures. Once this rain falls, it is absorbed by the soil, taken up by the plants, and transpired again into the atmosphere, where it continues the cycle of cloud formation and precipitation. This process, driven by vegetation, is part of the biotic pump, a natural system where plants release water vapor and bioaerosols, creating a self-sustaining cycle of evaporation, cloud formation, rainfall, and transpiration. The biotic pump regulates local and regional climates, maintaining consistent rainfall patterns and cooling the surface. Every blade of grass and every leaf on vegetation cools the earth while producing rain-making bacteria like Pseudomonas syringae. These bioaerosols seed clouds efficiently, even at low concentration, making vegetation a critical driver of the water cycle and rainfall. I call clouds that form primarily on mineral dust lithoclouds, and those that form on biological aerosols floroclouds. Lithoclouds are higher and thinner, trapping heat in the atmosphere, while floroclouds are known to be brighter and lower, reflecting solar radiation back into space and providing a cooling effect. The suppression of rain by lithoclouds often leads to a feedback loop. Hotter air holds more water vapor, trapping heat and filling the water bladder of the sky to a violent breaking point. When this hot air meets cooling formations of vegetation with bioaerosols, sudden ice nucleation occurs, resulting in massive storms, hailstones, and tornadoes. This dynamic is particularly evident in North America, in central United States, where the dry air from the west meets the moist air from the east. Severe weather events like tornadoes and massive hailstorms occur. Bare ground in the western plains contributes mineral dust to the atmosphere, suppressing rainfall until the hot, dry air collides with the moist air from the east. This leads to a sudden, dramatic rainfall, unloading often during plowing season, which coincides with peak hail and tornado activity. So what is more impactful on our climate? Carbon that builds up over decades and raises temperatures by 1 or 2 degrees, or the immediate effects of mineral and biological aerosols on water, our most abundant greenhouse gas. Mineral dust can suppress rain and lowering freezing temperatures by 30 degrees Celsius, disrupting rainfall patterns and causing drought and flood cycles. The interplay between bare ground, mineral dust, vegetation, and bioaerosols shapes our climate extremes, driving hurricanes, tornadoes, hailstorms, drought, and floods. This conflict highlights the urgent need to restore vegetative cover to stabilize the climate. Let's not forget that plants eat CO2 for breakfast. By covering bare ground with vegetation, we can mitigate CO2 levels while reducing harmful mineral dust aerosols. Plants absorb carbon dioxide during photosynthesis, storing it in the soil and promoting the formation of flora clouds that encourage consistent rainfall and cooling. To address these challenges, we can implement restorative practices that cover bare ground and restore ecological balance. Holistic grazing, managed grazing, mimics natural herd movements, improving soil health, promoting plant growth, performing rapid nutrient cycling, building a soil sponge to retain water, and reducing erosion. Cover cropping with crimping. Planting cover crops during off seasons protects the soil, enhances fertility, and prevents mineral dust from becoming airborne. Low-till, no-till farming protects soil structure, reduces erosion, retains moisture, and fosters rich carbon-sequestering soil for resilient agriculture. Agroforestry, integrating trees with crops and livestock boosts biodiversity, improves water cycle, and sequesters carbon while improving wind and sun protection in extremes. Water retention landscapes, designing landscapes to capture and retain water enhances groundwater recharge, supports vegetation, and reduces runoff. Planting mangroves on coastlines. Mangroves protect against coastal erosion, support marine ecosystems, and absorb significant amounts of CO2. Restoring ocean life. Protecting marine ecosystems, safeguarding marine ecosystems enhances bioaerosol production, which seeds clouds and regulates climate and supports the water cycle. By adopting these restorative practices, we can green deserts, reduce harmful aerosols, and enhance beneficial aerosols. This not only mitigates CO2 levels, but also promotes a more stable and balanced climate. Through collaboration and action, we can harness nature's mechanisms to combat climate extremes and foster a healthier planet.